All right, so welcome to the deep dive. Today we're going to be taking a look at some really cool research
Yeah,
on perovskite solar cells.
Perovskites. Yeah.
Yeah, they're pretty amazing.
Yeah.
So we're going to be focusing on the work of Somaya Abaspergomi.
Okay.
She's a young scientist who presented at the Youth Scientist Competition back in 2023. And we've got some excerpts from her research paper here.
Yeah.
And I have to admit, some of it went a little over my head,
Yeah.
so I'm hoping you can kind of help break it down.
Yeah, happy to.
Explain like why this research is such a big deal.
Yeah, perovskite solar cells are really interesting because they offer a potential alternative to like the traditional silicon solar cells.
Okay, so let's start with the basics.
Yeah.
What exactly are perovskite solar cells?
So perovskites are a class of materials that have a specific crystal structure.
Mm-hmm.
It's called an ABX3 structure.
Okay.
And what's special about this structure is that it's incredibly efficient at absorbing sunlight. Okay.
And converting it into electricity.
Gotcha. So even though they're different from, like, the silicon solar cells, they still do the same basic job,
Exactly.
which is turning sunlight into power.
Exactly. But the way they do it and the materials that they use are quite different. For example, at the A site of this structure, you have these large cations like formaminium or cesium.
Okay.
And these cations play a really big role in how well the cell absorbs light.
So it's kind of like the perovskite material is like a perfectly arranged solar panel city
Huh.
where each building is designed to capture those light particles and convert them to energy.
Yeah. Yeah, that's a great way to think about it.
Yeah.
And there's lead and halides involved too,
Oh, okay.
which are important for guiding those energy particles and creating a flow of electricity.
Okay, so how does Abaspergomi's research fit into all this?
Right.
What makes her approach to perovskite cells kind of stand out? Well, what's fascinating about Abaspergomi's research is that she developed a new architecture for these cells
Uh-huh.
called a PIM structure.
Okay.
It's kind of like a sandwich.
Okay, I'm intrigued.
Yeah.
Tell me more about this solar cell sandwich.
Yeah, so the bottom layer is a metal oxide, like nickel oxide, and this acts as the P-type layer, which attracts positive charges.
Mm-hmm.
Then you have the perovskite layer itself,
Okay.
which is where the actual conversion of sunlight to electricity happens.
Uh-huh.
And then finally, the top layer is the N-type layer,
Mm-hmm.
which attracts negative charges.
Okay, so it sounds like this PIN structure is pretty different from how, like, traditional perovskite solar cells are made.
It is, yeah. And it's a big deal because this new architecture could lead to more efficient and stable solar cells.
Gotcha.
Think about it. If we can improve the efficiency even a little bit,
Yeah.
it could have a huge impact on how we generate and use solar energy.
Okay, so efficiency is, like, a key factor here.
Yeah.
But I'm also curious about the process of actually, like, making these perovskite cells.
Yeah.
It sounds pretty complicated.
It's actually more complicated than baking a cake.
Okay.
But like baking a cake, it does require a lot of precision and control.
Mm-hmm.
Abaspergomi's research paper goes into detail about how each layer of the cell is carefully created.
Okay.
And it all starts with a technique called spin coating.
Spin coating. Okay.
Yeah.
I have to admit, the name makes me picture a carnival ride,
Sure.
but I'm guessing it's a little bit more complicated than that.
You're right. It's not quite as simple as spinning cotton candy.
Okay.
But the principle is actually kind of similar.
Mm-hmm.
So we use centrifugal force
Okay.
to spread a thin film of material onto a surface.
Gotcha.
In this case, we're talking about like incredibly thin layers of perovskite material.
So you're basically taking these materials and putting them in a high-speed blender.
Well, not a blender exactly. But imagine like a flat disc spinning really fast,
Okay.
and you carefully drop a solution of the material onto the center of the disc.
Mm-hmm.
And then the spinning motion kind of spreads the solution outward, creating a very thin and even layer.
Okay, so precision is key here.
Yeah.
Every layer has to be just the right thickness for the solar cell to work properly.
Yeah.
What happens after the spin coating?
After the layers are spin coated, they need to be annealed.
Okay.
Annealing is basically a heat treatment process
Mm-hmm.
that helps to crystallize the materials and make them more stable.
Okay.
It's kind of like baking a cake. You need the right temperature and time to get the perfect texture.
So you're telling me that the temperature of the oven can actually impact how well the solar cell works.
Absolutely. Yeah, the annealing temperature plays a crucial role
Wow.
in determining the size and the arrangement of the perovskite crystals, which directly affects the cell's efficiency.
I'm curious, what's the optimal temperature range for annealing?
Yeah.
And how did Abasbergomi kind of determine that?
That's a great question, and it's something that researchers are still investigating.
Uh-huh.
In her research, Abasbergomi experimented with different annealing temperatures
Okay.
for the nickel oxide layer and found that a specific temperature range resulted in the best performance.
So it's a bit like finding the sweet spot for baking a cake.
Yeah.
Too low and it won't cook through, too high and it'll burn.
Exactly.
Yeah.
Yeah. It's all about finding the perfect balance. Now, another interesting detail in the research
Okay.
is the use of an anti-solvent during the fabrication process.
Okay.
They use chlorobenzene.
Chlorobenzene.
Yeah, it sounds a bit scary,
Yeah.
but it plays a crucial role in controlling the crystallization of the perovskite layer.
Okay, I have to admit, chlorobenzene doesn't sound very friendly.
Sure.
Can you explain why it's important in a way that even I can understand?
Um, think of it like adding a secret ingredient.
Okay.
That helps the cake rise properly.
Okay.
The chlorobenzene helps to slow down the drying process of the perovskite layer,
Mm-hmm.
allowing the crystals to form in a more organized and efficient way.
So every step in this process is carefully controlled to maximize the performance of the solar cell.
Right.
We've got the spin coating, the annealing, the secret ingredient,
Right.
all working together to create this high-tech energy converter.
You got it.
Yeah.
And the results are pretty impressive.
Okay.
In her lab scale testing, Abasbergomi achieved a 12% efficiency level.
Now, you might be wondering, 12%, is that good?
Mm-hmm.
Well, let me put it this way. Abasbergomi achieved a 12% efficiency level, which is remarkable considering this is a lab-scale experiment.
Right.
Most traditional solar panels are only around 15 to 20% efficient.
Yeah.
This means that perovskite cells have the potential to catch up quickly.
Exactly. And that's what makes this research so exciting.
Yeah.
Yeah.
It's
It is.
it really is.
Yeah, and remember, this is just the beginning for perovskite solar cells.
Mm-hmm.
The fact that they're already achieving these kinds of efficiencies
Yeah.
at like such an early stage of development,
Right.
it's incredibly promising.
Okay, so we've got these like efficient, potentially cheaper solar cells.
Yeah.
What's stopping us from putting them on every rooftop right now?
Well, there are still some challenges to overcome. One of the big ones is scalability.
Okay.
You know, it's one thing to make these cells in a lab,
Right.
but it's quite another to mass produce them
Yeah.
while maintaining that high level of efficiency and stability.
So it's like the difference between baking a single cake and running a bakery.
Exactly. You
Yeah.
need different processes and equipment
Right.
to produce on a larger scale.
Okay. And there are other like technical hurdles as well.
Yeah.
Remember that hysteresis issue we talked about earlier?
Oh, yeah.
That tendency for the cell's performance to like fluctuate
Yeah.
based on its past usage.
Right.
That's something researchers are actively working on.
Yes, absolutely.
Like that solar cell memory thing.
Yeah.
What are some of the ways that they're trying to like address that?
Well, one approach is to, tinker with the perovskite material itself
Okay.
by tweaking the composition, like experimenting with different combinations of organic and inorganic components.
Mm-hmm.
They're trying to find like the most stable and efficient mix.
This is back to that recipe analogy.
Yeah, exactly.
They're fine-tuning the ingredients to create a perovskite solar cell that's both powerful and reliable.
Precisely.
Yeah.
And another area of focus is improving the interfaces between those different layers in the solar cell.
Okay.
Remember that PIN structure?
Right, yeah.
The way those layers interact can significantly affect the cell's performance and how long it lasts.
It's like making sure all the layers of the cake stick together properly.
Yeah.
And don't slide around.
That's a great way to put it.
Yeah.
Yeah, researchers are exploring different materials and techniques to optimize those interfaces and make the cell as efficient as possible.
So even though there are challenges, it sounds like there's a lot of like exciting progress being made.
Absolutely.
Yeah.
And it's not just about the technology itself.
Mm-hmm.
Abasbergomi's research also highlights the importance of thinking about like the bigger picture, the
Wow.
potential impact of perovskite solar cells on society as a whole.
That's a great point.
Yeah.
It's not just about like watts and volts.
Right.
It's about how this technology could like change the way we live
Exactly.
and interact with the world.
Yeah,
So,
imagine a world where solar energy is more affordable and accessible.
yeah,
It could transform communities, especially in developing countries,
right.
by providing a clean and reliable source of power.
It could also help reduce our reliance on fossil fuels,
Absolutely.
which would be a huge step forward in addressing climate change.
Yeah, absolutely. And because perovskite solar cells can be made flexible,
Right.
we could see them integrated into all sorts of things. Clothing, tents,
Wow.
even curved surfaces like car roofs.
So we're talking about a future where solar energy is like seamlessly woven into our lives.
Yeah.
That's pretty amazing to think about.
It is, but it's important to remember that there are also potential challenges and considerations. As with any new technology,
Yeah.
we need to think carefully about the environmental impact of production and disposal.
That's a good point.
Yeah,
We don't want to solve one problem by creating another.
exactly. We need to make sure that the materials used in perovskite solar cells are sourced responsibly
Hmm.
and that there are proper recycling methods in place.
Right.
But I'm optimistic that with careful planning and continued research, we can harness the power of this technology for good.
It's inspiring to see like a young scientist like Abbas Bergomi, not just focused on the science itself,
Yeah.
but also thinking about the broader societal implications.
It's a good reminder that scientific innovation should always be in service of humanity and the planet.
Now, going back to the research paper for a moment,
Yeah.
I was really struck by the images included.
Oh, yeah.
They're not just like graphs and charts.
Right.
They're these beautiful, almost artistic representations of the science.
Oh, absolutely.
Yeah.
Those images really, really help to bring the research to life.
Yeah.
For example, there's a scanning electron microscope image, or SEM image,
Okay.
that shows the network of nanofibers formed during the perovskite layer creation.
No.
It looks like a delicate, intricate web.
It's incredible to think that those tiny fibers are playing such a crucial role
I know.
in how the solar cell functions.
They do. They act as like scaffolding during the crystallization process, helping to guide the formation of larger perovskite grains, which ultimately leads to better efficiency.
So those images aren't just pretty pictures. They're providing valuable insights
Exactly.
into the inner workings of the solar cell.
Exactly. And there are other images that illustrate the effects of annealing temperature on crystallization, showing how the arrangement of atoms changes at different temperatures.
So we can actually see how like tweaking that baking temperature
Yeah.
impacts the structure of the material. That's amazing.
It is, and then there are images from thermogravimetric analysis, or TGA,
Okay.
which show how stable the different precursor materials are at high temperatures. This helps researchers ensure that the materials can withstand the heat treatment process without breaking down.
So these images are like windows
Yeah,
into the microscopic world of perovskite solar cells,
they are.
revealing the intricate processes that make them work.
And by studying these images, researchers can gain a deeper understanding of how to optimize the fabrication process and ultimately create even better solar cells.
It's fascinating to see how like science and art can intersect in this way.
It is,
Yeah.
and it highlights the importance of visualization in scientific research.
Right.
Sometimes a picture really is worth 1,000 words.
Speaking of the bigger picture,
Yeah.
I'm curious to hear your thoughts on where this technology is headed.
Right.
What do you think the future holds for perovskite solar cells?
Well, it's still early days,
Sure.
but the potential is enormous if researchers can overcome the scalability and stability challenges.
Right.
I think we could see perovskite solar cells playing a major role in the future of renewable energy.
What about efficiency?
Yeah.
Do you think they could eventually surpass traditional silicon solar cells?
It's certainly possible.
Yeah.
Perovskite materials have a unique ability to convert sunlight into electricity. And there's still a lot of room for improvement in terms of efficiency.
And as we talked about earlier, the versatility of these cells
Right.
opens up so many possibilities.
Yeah.
We could see them integrated into buildings, vehicles, even clothing.
Exactly. Imagine a world where almost any surface could be used to generate solar energy.
Yeah.
It could revolutionize the way we power our lives.
It's an exciting vision.
It is.
And I have to say, I'm feeling pretty optimistic after this deep dive.
Me too.
Yeah.
Perovskite solar cells represent a real breakthrough in renewable energy technology,
Mhm.
and I'm eager to see what the future holds.
Before we wrap up,
Yeah.
is there anything else you think our listeners should know about this topic? Any like key takeaways or things to keep in mind?
I think the biggest takeaway is that scientific innovation is a journey, not a destination.
Mhm.
There are always challenges to overcome,
Right.
new discoveries to be made,
Yeah.
and the potential for unexpected breakthroughs.
That's a great point.
Yeah.
And it's important to remember that even like young scientists like Somaya Abisbergomi
Yeah.
can make significant contributions to advancing our understanding of the world.
Absolutely.
Yeah.
Her work on perovskite solar cells is a great example of the power of curiosity, creativity, and perseverance.
And it's a reminder that the future of science and technology
Yeah.
depends on encouraging and supporting young minds
Yes.
who are eager to make a difference.
I couldn't agree more.
Yeah.
The world needs more curious, passionate individuals like Somaya who are willing to ask bold questions and push the boundaries of what's possible.
Well said.
Yeah.
This deep dive has been incredibly insightful.
Yes.
And I have to say, I'm feeling pretty inspired right now.
Me too. It's been a pleasure discussing this fascinating topic with you.
You know, as we've been talking about all this, I've been thinking about how this research connects to like a bigger theme.
Ooh.
I'm intrigued. Well, we've been talking about this amazing technology and the potential it has to like change the world. But
Right.
what really struck me was like how Abisbergomi's research started.
You mean the fact that she was so young when she presented this work?
Exactly.
Yeah.
It's a good reminder that groundbreaking ideas can come from anywhere and anyone,
Absolutely.
especially like young minds with fresh perspectives.
I completely agree. Sometimes it takes a fresh set of eyes to see a problem in a new way
Mhm.
and come up with a creative solution.
Right.
And Abisbergomi's work is a perfect example of that.
It's like she approached this challenge without any preconceived notions
Uh-huh.
and just let her curiosity guide her.
That's the beauty of science, isn't it?
Yeah.
It's all about asking questions,
Mm-hmm.
exploring the unknown,
Yeah.
and pushing the boundaries of what we know.
And it's not always a straight path to discovery.
Right.
There are setbacks, unexpected turns,
Yeah.
and sometimes even happy accidents
Absolutely.
that lead to breakthroughs.
Yeah, science is a process of trial and error,
Mhm.
experimentation and collaboration.
Right.
And it's often those unexpected moments,
Well.
those aha moments
Right.
that lead to the most significant advancements.
And those moments can happen to anyone, regardless of age or background.
Exactly.
Yeah.
So if you're listening to this
Mhm.
and you have a curious mind,
Yeah.
don't be afraid to ask questions.
Right.
Explore your interests
Mm-hmm.
and pursue your passions.
You never know what amazing discoveries you might make.
And who knows,
Yeah.
your curiosity might just lead to the next big breakthrough that changes the world.
Well said.
Yeah,
This deep dive has been incredibly insightful.
it has.
And I have to say, I'm feeling pretty inspired to learn more.
Me too. It's been a pleasure exploring the world of perovskite solar cells with you.
And to our listeners, we hope this deep dive has sparked your curiosity about this amazing technology
Yeah.
and the potential it holds for a brighter future.
Remember, the future is powered by innovation,
Mhm.
and that innovation starts with you.
So keep those minds curious,
Mhm.
stay engaged,
Absolutely.
and never stop exploring.
Thanks for joining us on the deep dive.